Hey guys, I was just at the high school near me and I was doing camp there, and I decided that when I got home I would make a video for you guys. And I'd like to discuss a type of number that is a category where my favorite number belongs in. So, about 5 months ago I made a video about 142,857 and the fact that it's my favorite number because just in case you haven't seen the video yet, here are the first 7 multiples of that number. We have times 2, we get 285,714. And you can see that it's literally just 142,857. Same thing as here, 142,857. Another example is if you take times 4, which you get 571,428. You can see it's just 142,857. See that? The same rules apply for these other multiples, but this number only has 6 digits, so we can only go up to the 6th multiple, which is 857,142. But take it a step further, multiply by 7. You get 999,999. It's because 1 over 7 is this number repeated infinitely. And anyway, let's jump right into the category. So, this category of numbers is called cyclic numbers. And this number is not the only one that does this. This is the smallest number that has this property. The next one after this one is 588,235,294,117,647. This is also a cyclic number with 15 digits. And technically there should be a 0 at the beginning. I'll put that there for you. Can't really see it because it's just squeezed into there. And this number, if you multiply it by 2, you get 1176470588235,294. And you can see, look at it, it's 058823529411767. You can see how that's just that, but looped from a different starting point. Do that on any number up through 16, and you'll get that. But if you were to multiply it by 17, you'll get 9,999,999,999,999,999,999. So that's another one of my favorite numbers. And the next one that comes after that is even bigger, except instead of having 15 digits, it has 17 digits, which is not far off. It's 52,947,368,421. This is another cyclic number. And one thing you can do about it is multiply it by 2, and you get 1052631573847368421. You can see that, right? It starts here, and then it goes back to the beginning with a 0, and then repeats that. Wait, this shouldn't be here. There shouldn't be a 1 at the end. But either way, the math is still correct. It ends with 2. And what's cool about it is that you can take this 1 right here and add it to the rest of the number and bring it over here. You just have to move this 1 to the start to get this number multiplied by 2. And if you were to multiply that by 19, you get all the 9s. And there's an infinite number of these. And the way you do it is you take a prime number, for example 113, and you take 10 to the power of 113, or any other prime number like that, and subtract 1. And then what you do next is subtract 1 from 113, so it should be 10 to the 112th power, and then divide it by 113. So the formula for a cyclic number is 10 to the p minus 1 divided by p, where p is a prime number. The reason why I picked 113 is because it's another cyclic prime number. It's a prime number that can form a cyclic number if you do that formula. And another reason why I picked it is because somewhere in that cyclic number, pi is hidden. Like, you could approximate pi using 355 over 113. This equals 3.1415926. Just kidding. 92. It doesn't go 6, but it's still extremely close to pi, and it's the best approximation of pi using only 3-digit numbers. There's other better approximations for pi, but those can be formed from those things. And for some reason, do you know what else is a prime number that can form a cyclic number? 13,463. This can form a cyclic number if you divide 1 by it. But it's going to be an extremely large number. Try writing down 1 over 13,463 in the full repeating decimal format for me, and see if you can figure out what it is. You don't have to do it, though. I'm not forcing you, but it's going to be a very big number. Trust me on that.